Hello, childrens. So, second lesson, or the third for some, of quantitative chemistry. Quantitative being amounts, measures, etc. And here, over this side, is the diagram of a molecule of glucose. Hopefully from the last topic, you'll see that these lines in between, like this one, I'll just put a line through, represents a covalent bond. And here we've got oxygen atoms and hydrogen atoms, and the black ones are representing carbon atoms, the red oxygen and the white's hydrogen. So you can see there's quite a few oxygens in here, the red ones, and there's quite a few carbons. How much carbon could you get from this? How much hydrogen could you get from this? What mass of hydrogen could you get? And that's what we're moving on to today. What is the mass of different atoms? What's the mass of this? How does it compare to that? And when you add them together, what's the mass of this molecule here? How do we work it out? By adding together the mass of this, this and this. And they're the things you'll be able to do by the end of this lesson, hopefully. So, a few recap questions first of all. So what you normally do is pause now, write out the question, write out the answer, and then I'll go through the answers and you can mark them. So pause now for a couple of minutes, do that, and then unpause and I'll go through the answers. And welcome back. So the relative mass of a proton, the mass of a proton is equal to the mass of a, so the other one with a mass was a neutron. It's neutrons and protons that weigh 1 each. They both have an atomic mass of 1. A charged particle is an ion. What bond would between a non-metal and a non-metal? Non-metal and non-metal are where they do the sharing, so that would be called a covalent bond. Who did the plum pudding model? Well, it was Dalton who did the atom, then the plum pudding was the second guy, so that is Thomson. And giant covalent substances can all conduct electricity, true or false? And the answer is, of course, false. We have graphite and graphene and fullerenes that can conduct electricity, but then we have diamond that doesn't conduct electricity. So it's false because it's not all of them that conduct electricity. Okay, hopefully you either did quite well on that, or if you've made a few mistakes, you make a few corrections, and the next time you get that right. Okay, this is going to be one of those, pause for a minute again and have a look. This is going back to last lesson. What's the law of conservation of mass? With this reaction, you explain how you know it is not balanced. You try to balance it. You then try and come up with an answer for this and try and explain why. So pause now and see if you can do that for yourself, even if you think it through. Answer each of those questions and then we'll go through and see how clearly you got last lesson. Okay, hopefully you're not cheating and you have now unpaused. What's the law of conservation of mass? Well, the mass of the reactants that you put into a reaction equals the mass of the product you make. They will always be the same. If you put in 100 grams of reactants, you'll get out 100 grams of products. How do we know this reaction isn't balanced? Because there isn't the same number of chlorines on both sides. So it's the chlorines here for this second part. How do I know it's not balanced? That bit, it's the number of chlorines. To balance the equation, I need to do Na, I'm just writing out the original equation, turns into sodium chloride. I will need to make 2 of these, and therefore I need to put 2 of these in, and now that's balanced. 2 sodiums this side, 2 sodiums this side, 2 chlorines this side, 2 chlorines this side. This question, if we use 20 grams of sodium and we make 110 grams of this sodium chloride, how much chlorine was used? Well, 20 grams plus something makes 110, so it must be 90 grams. And explain your answer, well, 110, if you take away the 20 that was sodium, it equals 90, which must have been chlorine. 90 grams of chlorine. Okay, If you're struggling with that, if you need to send questions to your teacher, feel free to. Hopefully you got most of that, and if not, hopefully you understand it a bit better now. So moving on to this. A couple of fairly straightforward things today. You need your copy of the periodic table in front of you. And the first thing is, what's the mass of an atom? Well, next to every atom on the periodic table, so for example, next to the atom carbon, it has 12 and it has 6. This was the atomic number, and this is called the mass number, and that tells us the total of protons plus neutrons. So it's the mass of the atom. So when we talk about a relative atomic mass, it is just the mass of an atom. So on the periodic table, and as I've just said, the mass of a carbon atom is 12. The mass of an oxygen atom, as you can see, is 16. Can you draw the table out, and can you then fill in the masses for the other atoms on this table? And that should be visible in the work you send through to your teacher. Okay? I'll give you another one anyway. Sodium. Hopefully you found it in group 1, 23. So fill in the masses, and then you've had a bit of practice, and in your notes it's always the bigger number that we're looking for the relative atomic mass. So now we go on to relative formula mass. So we've just dealt with A and a small r, and now we deal with mr. This is the mass of atoms, and this is the mass of molecules. If I wanted to work out the mass of this rather large Triceratops head, and I knew the mass of one Lego brick that was blue, and they were all the same size, I could times it by a number of more. And if I knew the yellow ones had a different mass, I could times it by that. So the total mass of this model would be all the bricks added together. And that's what we're doing with molecules. So what is the mass, or the mR, of H2O? Sounds like a complicated question. Work out the relative formula mass of H2O. Well, actually, before you make a judgment and say, oh, this is really difficult, just think about it. It's actually asking you to work out the mass of a H2O, like we've been drawing when we did our covalent bonding. So, just what you did a minute ago was you worked out that, for example, the mass of a hydrogen is 1. The mass of the other hydrogen is 1. The mass of an oxygen is 16. So 16 plus 1 plus 1 is 18. The answer is 18. Now that's a very straightforward one, and some that you're asked to do could be really complicated. And so there's actually a structure for working them out. We'll come to that in a second. So this structure, EMNS, what element is it? What's the mass of it? Just like we've been doing, there's the periodic table, you've got your element, you've got your mass. How many of them do you have, and what's the subtotal? So what we do is, here's my chemical, nitric acid, HNO3. So my first element is hydrogen, that goes in there. My second one, nitrogen, and then my third one, oxygen. I look at the periodic table and I look at the mass of this is 1, the mass of this is 14, and the mass of this is 16. How many of them have I got? Oh, I've got one H there. I've got one N. And I've got, oh, there you go. That's where people go wrong. They just add the 16 on. There's 3 of them. And then I work out my subtotals. Well, 1 times 1 is 1. 1 times 14 is 14. And 3 times 16 is 48. So my subtotals are here, and then I add them all together. 48 and 14 is 62, plus 1 is 63. That means the MR, the mass of this molecule, equals 63. So please write this one down as an example. Draw your little table. Always E, M, N, S. Now what people usually do to help them remember things like this is they come up with something like elephants might not skate. There you go. Elephants might not skate, so they come up with a thing to remember it. Elephants might not skate, and what you picture in your head is you picture an elephant going skating on a frozen lake and going straight through the ice and becoming an ice cube. Elephants might not skate because they're very heavy and they break the ice. To try and remember element, mass, number, subtotal, and that way you won't forget the structure. So here we are. Next one. What's my answer? My answer is elephants might not skate. My elements are calcium, carbon, and oxygen. I have one calcium. Oh, no, mass first. Calcium, I look on the periodic table, it's 40. It's even here for you this time to help. Carbon is 12, and oxygen is 16. And like I say, some people just add them up then. That's why you want the structure, EMNS. How many have we got? We got one, we got one, we have 3. It says there, over this side, 3. So then I can go, well, that'll be 40, and that will be 12, because there's one of them, and 3 of those, still 48, just like it was a minute ago. And then I add together the subtotals, and I have 88 and 12. Oh, wow, it's around 100. The MR of CaCO3 is 100 atomic units. Okay, your go. Draw your little table. Have a go. If you need to go back in the video to a minute ago and actually have a look at it and do the table and the notes as a second example, and then do this one. So you do your E, M, N, elephants might not skate, element, mass, number of those atoms, and then do that. Right, please have a go yourself and then unpause when you're ready. Okay, so if you put down C and O, give yourself a mark. If you then correctly got them from the periodic table and got 12 and 16, give yourself a mark. If you wrote down there's 1 of those and 2 of those, give yourself a mark. If you then did 12 and 32, give yourself a mark. And if you then put down that the total was 44, give yourself your 5th mark. And that would mean you're getting this and you understand. And now over to you. If you are going for grades 1 to grade 5, please can you do these 5, sorry, there's 6 of them, do those 6 in little tables and then submit that work to your teachers. And if you're aiming at above a grade 5, can you also do these and submit those? Therefore your teacher can give you feedback on it. The only thing I'll say about it is brackets are exactly the same as in maths, so you always do your brackets first, and that 3 there on this, well actually on this example over here, if you read through it, there's a worked example here to help you before you do the grey ones. That 2 there means there's 2 lots of everything in the brackets, so there'll be 2 oxygens here, 2 hydrogens, so 2 oxygens, 2 hydrogens, and just 1 calcium. So the worked example there is for the people going for those higher grades. Then you submit it to your teacher. Okay, well done and good luck.